welcome back to AGT STEM. Today we're going to be watching a video about lutetium. So, without further ado, let's hop to it.
We're going to tell you about lutetium, element number 71. It's quite a bit of argument whether it's the last of the rare earths or a member of group 3 in the periodic table, but we'll come to that later. We're going to show you some demonstrations, particularly a terrific red colour that you can get from it. The element was discovered in 1907 by two chemists almost simultaneously. French chemist Georges Urbain, who eventually got the credit and therefore was allowed to name the element, and the German chemist Auer von Welsbach, who was rather older than Urbain. They both separated it from a mixture of other rare earths, particularly from an ore containing ytterbium. At that time, there was enormous arguments whether the different elements that had been isolated were really pure or actually mixtures of more than one element. And Urbain published his paper in French, then eventually, and it took a couple of years, was allowed to name it, and he called it lutetium, which is named after the Latin name for Paris, which I think was called Lutetia. And so a very patriotic name, which probably also annoyed Welsbach, who named his element cassiopeium after a Greek queen, Cassiopeia. I can't remember, somewhere in Greek mythology. He gave it the symbol Cp, which was therefore the reason why element 112, copernicium, was eventually given the symbol Cn, not to be muddled with this non-existent element of Welsbach. For some reason, lutetium is extremely expensive, so we only had very small pieces of the metal and a tiny bottle of lutetium nitrate. So we couldn't do huge experiments. Lutetium salts are nearly all colourless, and I wanted to try and find a coloured one. So I read that the iodide of lutetium could be yellow, and I persuaded Neil to try mixing potassium iodide with lutetium nitrate. It was very boring. Two colourless solutions mixing, nothing happened.
Give it a squirt. Boring.
We had a bit better luck mixing sodium sulfide with lutetium nitrate. Lutetium sulfide precipitated. It was a whitish colour, but with the eye of faith you could argue it wasn't pure white, but it wasn't a very convincing colour. There was still a bit of lutetium nitrate left, so I persuaded Neil to try heating it. Very often, if you heat nitrates of elements, they will give off NO2 gas, which are brown, and form the oxide. And after a bit of heating, indeed, you could see a brown gas. So lutetium nitrate behaves like other nitrates. Now, Neil and I had both read that lutetium was meant to burn at a very low temperature. So he tried putting a piece of metal, lutetium metal, into a flame, and nothing happened. Came out just about the same. So he got his powerful oxygen gas torch, which has a flame that burns at a much higher temperature, used for cutting through steel and things like that.
Well.
And then, when he heated up the lutetium, he had two samples, some small lumps.
It's very big, bright light.
And also a small strip of the metal, and those really did burn.
I find it kind of strange how it went in a perfect star pattern,
Also a small,
it's almost like a perfect star. Well, it has 6 little things. Whatever. It's still a star.
strip of the metal, and those really did burn. But the real surprise to us is that it gave off a really nice red colour. And we hadn't been expecting this, but if you have seen other elements when they burn or you put them in the flame in some of our other videos, you will see that elements often give a very nice characteristic colour. And so now Neil and I and you realise that lutetium gives a really nice red colour.
What's lutetium used for in the world?
Well, it's not used for very much. You can add it to a mixture with yttrium and aluminium to make so-called garnet, which can be used for LEDs, LED lighting, and which gives off a different colour from some of the other light-emitting diodes. The radioactive isotope of lutetium, lutetium-177, can be used for treating prostate cancer, a very unpleasant disease that affects a lot of men. And you can attach the lutetium to a molecule which will be absorbed selectively by the tumours, so the radioactivity can be targeted on the tumours and can kill the tumours. Unfortunately, it doesn't work for all sufferers from prostate cancer, but it seems to have at least some promise. The final application, which is more a piece of analytical chemistry, is that you can look at the ratio of lutetium and hafnium isotopes in objects that come from outer space, meteorites, for example, and from the ratio of these isotopes, you can calculate how many billions of years old these meteorites are. And it is quite an effective way of dating these objects from space. This is not really a very practical application, but it's really quite an interesting piece of science. There has been quite a lot of argument recently where lutetium fits in the periodic table. If you have an older periodic table, lutetium will be in group 3 near the bottom. A more modern periodic table, you will find that lutetium is right at the end of the row of the rare earth elements, one of the rows at the bottom of the periodic table in a separate block. There's still quite a bit of argument.
It's kind of, I don't, why would, it's kind of, it's weird that they're arguing about where an element should go in the periodic table. It seems like a lame thing to argue about. Like, they're put in this order for, like, a bunch of reasons, and then you're trying to move things around. It's weird.
Whether it's in one position or the other. My personal feeling is that this is not a terribly important point. What is an important point is that it is element number 71 and comes between 70 and 72. Where it actually fits on the periodic table doesn't worry me so much. But the real lesson that I got from this is that lutetium gives a fantastic red colour.
This episode was brought to you by Kiwi.
Thank you so much for watching, and we'll see you next time. Stay smart. Bye.